Hello everyone, welcome back to the channel. If I talk about the qualities of incident responder or a threat hunter, the first quality one should have is to quickly spot the anomaly from the normality. And this quality could only be cultivated when one is aware of the normal. So today this is what we are exactly going to see. I will be looking at the Windows core processes and the parent-child relationship among them. The process which I'm going to discuss are responsible for the Windows most basic functions. The functions like Windows API, ability to authenticate users, providing GUI to users, etc. We will try to understand what is the baseline for these processes, what is their normal behavior, and then finally look into them through the Process Explorer in the live windows. Before we start, I would recommend you to download this free Sans DFIR poster which is named as Find Evil No Normal. Let me drag it to the screen first. This is the crux of this video and will come as handy in remembering the normal behavior of Windows process. I have shared its link in the video description below and you can quickly go and download it from there. Having said that, let's get started. So the very first process which comes into picture when we start our Windows machine is system process. System process hosts most of the kernel mode threads. The modules that run under system process are drivers, that is .sys files, and some important executables like NTOS kernel.exe. There is no image path associated with this process, which basically means that there is no executable file like system.exe available on disk which initiates it. User account associated with it will be anti-authority system. There will be no parent process for this. There will be no command line argument associated with it. The process ID will always be 4. This is the one thing that we should always remember about system process. The number of instances will always be 1. If we are seeing more than one, then that is suspicious and need to be investigated. And the final thing to remember is that this process should always be running in session 0. If you guys are not aware of the term sessions in Windows, then please follow the blog post link that I have shared in the video description. Now system process initiates smss.exe, which is session manager subsystem. This is the first process in user mode. The session manager's process is responsible for creating new sessions and the environment variables. It also starts the kernel and user modes of Win32 subsystem, which is also known as Windows APIs. One important thing to note during process lineage analysis is that smss.exe created by system process is known as master smss.exe. This master smss.exe then further creates child instances of itself. The count of these child instances will depend on the number of sessions running. These child smss.exe further initiates CSRSS.exe in each session, wininit.exe in session 0, and process winlogon.exe in session 1. Once these processes are initiated, the child instances of smss.exe will exit. Now, what is normal for this process? Normal for smss.exe is to have image path as system root system32 smss.exe. Process initiating from any other directory other than system32 is clear case of malware. User associated with this process will be anti-authority system. Parent process will always be system and the number of instances will only be 1 after boot up. CSRSS.exe, also known as Client Server Runtime Subsystem, prior to the release of Windows NT 4.0 in 1996, it was CSRSS.exe responsibility to support the entire graphical user interface subsystem that include controlling windows, drawing on screen, and similar other OS-based functions. However, with the Windows NT 4.0 launch, most of these functions went obsolete from CSRSS.exe. But the client's server runtime process still supports the Windows console and process of Windows shutdown. Now, what is normal for CSRSS.exe? Normal for CSRSS.exe is to have image path as system root system32 CSRSS.exe. User account should always be anti-authority system. Parent process is child SMSS.exe which is existed, hence it will not be visible in Process Explorer. If Process Explorer displays the parent process of CSRSS.exe, then that demands further investigation on that process because that is not a normal behavior. Number of running instances will be number of running instances for CSRSS.exe will be at least two instances, one instance in session 0 and another one in session 1. Now let's see wininit.exe, also known as Windows initialize.exe. WinInit.exe starts key background processes within session 0. It is the core process that first appeared in Windows XP. It reads and processes the commands stored in the file wininit.ini, which ultimately allow programs to take actions while the computer is still in booting mode. It primarily acts as a launcher for the majority of background applications that are always running. What is normal for wininit.exe? Well, the image path should be system root system32 wininit.exe. User account will be anti-authority system. Parent process again will not be visible as child instance of smss.exe is exited. Number of instances will be 1 and that to be running in session 0. WinInit further initiates child processes such as services.exe, LSAiso.exe, and LSAiso.exe. This process will be initiated if credential guard function is enabled in Windows 10. Let's look at the services.exe first. Services.exe, also known as Service Control Manager, as the name suggests, this process is responsible to start, stop, and interact with Windows services. This implements the Unified Background Process Manager (UBPM), which is responsible for background activities such as services and scheduled tasks. Services.exe also launches the auto start services and drivers by reading the registry key, which is available at registry path HKey local machine, system, current control set, services. Once the user is successfully logged into the machine, then services.exe loads the content of registry key last known good control set to the value of registry key current control set. Now what is normal for services? Services.exe will always run with session 0. Its image path will be system root system32 services.exe. User account associated with it will be anti-authority system. Parent process will be wininit.exe and the number of running instances will always be 1 and that too in session 0. LSS.exe, also known as Local Security Authentication Subsystem, is a user mode process that is responsible for authenticating users by calling an appropriate authentication package, which is specified within the registry key. Typically, this authentication package will be Kerberos for domain accounts or MSV1 for local accounts. In addition to authenticating users, LSS.exe is also responsible for writing events to the security event log and for implementing the local security policies such as password policies and audit policies. Now, what is normal for LSS.exe? Normal for LSS.exe is to have image path as system root system32 LSS.exe. User account should be anti-authority system. Parent process should be none other than wininit.exe. Number of instances should always be one instance, and it should not have any child process. Only exception is EFS when encrypting file system is enabled for NTFS drives. LSS is one of the most targeted Windows processes by malwares. LSS stores the password hashes, hence it is targeted for password dumping attacks. Its process name is also mimicked by malware to hide in the plain sight. For instance, processes named as LASS.exe, LSSASS.exe, or LSASSExe, etc. are all fake names and will not have a parent as wininit.exe. LSAiso.exe, also known as LSAisolate.exe, As the name describes, this is an isolated LSA process which runs in virtualized environment by leveraging the hardware virtualization technology. LSAiso.exe appears in the process tree when credential guard is enabled in Windows 10. This provides the added security against the credential dumping attacks which LSS.exe had to face. Normal behavior of LSAiso.exe is to have image under the path system root system32 LSAiso.exe. It uses anti-authority system account. Its parent process will be winInit.exe and the number of instances will always be 1. Important point to note here is that this process should only appear in process tree if credential guard is enabled in Windows 10. Now among these three processes, only services.exe will usually have a child process which is svchost.exe. svchost.exe is also known as service hosting process. This process hosts multiple DLL files of multiple services for implementing the shared service model, which usually helps in preserving the CPU resources. But this is no more valid from Windows 10 version 1703 onwards, where the services will now be hosted in their individual svchost.exe process if the machine has a memory more than 3.5 GB. Genuine svchost.exe will have its image under the path system root system32 svchost.exe. In operating softwares prior to Windows 10, the user account used by svchost.exe was now anyone from system, local service, or network service. Whereas in Windows 10, some instances can run with logged in user account as well. The parent process will always be services.exe and the number of instances will be multiple depending upon the number of running services. One important thing to note is that the genuine svchost.exe command line argument must contain -k parameter. Command line other than this is a clear case of malware. Like LSAiso.exe, this process has also been the target of malware developers due to its ubiquitous nature, which allows malware to hide in a plain sight by just a simple juggle of alphabets in process name spelling. For example, a process name as scvhost.exe can easily hide under an untrained eye. Now svchost.exe further have task host w.exe and runtime broker.exe as child processes. Let's first look at the task host w.exe. This process hosts DLL files which are related to scheduled tasks. This process continuously listens for the triggers to initiate the task accordingly. Microsoft has renamed this host process multiple times. In Windows 7, it was named as taskhost.exe. In Windows 8, it was called taskhostEX.exe. And now in Windows 10, the new name is taskhostw.exe. So just by looking at the name of the task host process, we can recognize the OS versions now. Its image path, its image path will be system root system32 task host w.exe. User account will be the logged on user account or local service account, and the parent process will be svchost.exe, and the number of instances can be multiple instances. Runtime broker.exe. This process was introduced in Windows 8 and is available in Windows 10 as well. Task of this process is to check for the Windows Store applications required permissions such as location access, microphone access, etc. Its image path will be system root system32 runtime broker.exe. Process will run under the logged in user account. Parent process will be svchost.exe and the number of instances will be one instance per UWP, which is Universal Windows Platform. This is a fancy name of Windows Store apps. WinLogon.exe. WinLogon.exe handles the interactive user logons and logoffs. It launches logonui.exe, which runs the credential provider to collect the credentials from the user. Once it has the credential, it passes them to LSS.exe for the validation. When the users are authenticated, then WinLogon loads the user's anti-user.dat file into current user registry Hive and start the user's shell, which is usually explorer.exe, via userinit.exe. Userinit.exe will exit after running the initial scripts and initiating the explorer.exe. Hence, this process will not be visible in Process Explorer. The normal behavior for WinLogon is to have its image under system root, system32, winlogon.exe. User account will be anti-authority system. Its parent process will be the exited child instance of sms.exe, hence will not be visible in Process Explorer. Number of instances will be one or more depending upon the logged in sessions. And finally, the last process to look at is explorer.exe. This process provides default user shelf or interface to end users through which they can interact with the windows. Its image path will be system root explorer.exe. This is the important point to note here. Explorer.exe is the only process among all the processes which we have seen so far that do not initiate from system32 directory. User account for explorer.exe will be the logged in user ID. The parent process will be user init.exe, which will not be visible in Process Explorer, and the number of instances will be one or more depending upon the logged on users. So for the next section of this video, we will be looking at Windows process on live machine. I am currently inside Windows 10 virtual machine and I am using Process Explorer for viewing and running process. Process Explorer is a free window utility developed by Sysinternal. This tool is used for monitoring or as a task manager. So I have already started it and it has already captured all the running processes on the window machine. So as we have discussed in the previous section of this video, the first process in the hierarchy should be system process. As we know, it should have the process ID as 4 and user account as system. Also, it should be running in session 0 and should not have any executable file on the disk. Hence, we can see the file path section of system process as blank. Further, if we look into in the hierarchy, system process should have child process as smss.exe, which is Windows Session Manager. As expected, it is running with the system account and under session 0 and has image file under system32 folder. Further, smss.exe will initiate its child instances, which will not be visible as we know those instances exit from the process tree post starting CSRSS.exe and winInit.exe in session 0 and another CSRSS.exe and WinLogon.exe in session 1. Let's verify winInit.exe as well. WinInit.exe, as expected, it is running with system's account under session 0 and has its executable image under C drive, Windows, System32, winInit.exe file path. WinInit should further initiate services.exe and LSSexe as its child processes. LSSexe, which is Local Security Authority process, is running with systems account under session 0 and has image path as Windows under System32. Also, there should be only one instance of LSSexe running in machine. Let's just verify it. As we can see, there is only one LSSexe under session 0 with executable image in System32 folder. If we check services.exe, it is also running with the expected values, which are a user account as system, session as 0, and file path as Windows System32 services.exe. Further, services.exe should have svchost.exe as its child process, and svchost.exe should have runtimebroker.exe and taskhostw.exe as its child processes. Now let's verify the processes under session 1. Let's quickly look into winlogon.exe. WinLogon.exe will initiate logonui.exe and userinit.exe as its child processes. Both of these processes will not be visible in the current process hierarchy. This is an expected behavior as we know they exit after performing their required task, which is logonui.exe will collect the credentials from the user and hand it over to LSAiso.exe for authentication purpose, and userinit.exe will run initial scripts and initiate explorer.exe as its child processes. Explorer.exe will further then initiates Windows graphical user interface for the applications, and this will be running in session 1 with its file path as c windows explorer.exe. We can see that this process is the only process among the above listed processes which is not initiating from system32 directory. So this is it guys. I have tried to cover the common required core processes of Windows. If this was helpful, then I would request you to like this video. And if you need any further assistance on this topic, please mention your query on the comments and I will be glad to address it. So thank you for watching and happy learning.